Next chapter, all to do with your geometry, is enlargements. Again, some of you could be very familiar with this and probably fly through it. Those of you who didn't do TG or DCG, just take your time, go through this video and go through the worksheet that I'm sending on as well with this. So, just a revision of your junior cert stuff. You have transformations. So your various transformations are, translation. You pick up an object and you move it. Okay. Central symmetry is where you maybe take a point, you go through a center point and out the same distance the other side. Take a point, go through a center point and out the same distance on the other side. Take a point, go through a center point and out the same distance on the other side. Central symmetry, through a point. Really familiar, I'm sure, with axial symmetry. And then the last one, you could have a rotation, just where you rotate something around. That's all junior cert stuff. Now we're going looking at enlargements. And the thing about even the word might throw you off. You could obviously, for an enlargement, you could be doubling something, right? So if we even look at this, the height of it from B to A is 1, 2, 3 high. 1, 2, 3, 4, 5, 6 is the image one. So we can clearly see we've doubled there. But also you could make the object smaller. Like you're not always making the object larger. You could actually be making the object smaller. So it's important that when we're drawing these that you know your center of the enlargement or your scale factor, which we called K. So in this situation, your scale factor is 2 because you're doubling everything. And the center of the enlargement is the point from which the enlargement is constructed. The scale factor, which we call K, is the number by which the object is enlarged. And then this is actually what I was just saying. Any scale factor that is greater than 1 will result in the image being bigger than the original object. So we call this the object and this the image of the original object. And then this is the other, any scale factor that is greater than 0 but less than 1 will result in the image being smaller than the object. This can still be described as an enlargement, but is actually more commonly called a reduction. Even looking here, you can see here's your original object. How do I know that? Well, they label the original object usually like A, B, or C, and then the image of it is A dash, B dash, C dash. Even when you look here, that's 6 boxes high. This one's only 2. You can tell scale factor. It went down by, let's say, you're dividing by 3. So 1/3 is your scale factor there. She says it at the top there. You can get your scale factor by putting your image length over your object length. And there, just wanted to show you, it's actually written down there for your scale factor. You can get your image length and put it over your object length. So I was off back here and looking at my image length my image length 2 over my object length 6, or you could have gone my image length root 13 over my object length 3 root 13, or 3 over 9, and no matter what way you do it, it would simplify always down to 1/3. So your scale factor there is 1/3. Few examples here for you if you want to have a try at drawing them. If you are asked, to take your image object, if you're asked to take your original, what's called an object, and do maybe an enlargement, then you start at your center of your enlargement, and if the length from 0 to A is 2 boxes, and they're asking you to enlarge it by 3, then the length from 0 to A dash or O to A dash should be 3 times what this is. So this is 2, and that means 2, 4, 6. There's your first image point. And you keep doing that. So let's say we measure the distance from O to C. Well, whatever that is, we need to multiply it by 3, and that should be the distance from O to C dash. And same here, and you just connect up, and you should have your original object, and now your image of your original object, which in this situation they asked you to do 3 times larger, so scale factor of 3. You can have a look at any of the questions here, any of the examples, try a few. I've also, with your email, I have sent you a worksheet on all of this, and I want you to print it out though. Like, you obviously need to be drawing these, not all of them, you can just do a bit of maths on. And just in case, this is the only other extra thing that you might not remember or might not have actually come across in TG. So if we look at the area of our objects, we have a length from B to C of 6 of your original object, and then it's 6 units here is what it's telling me, which means each of these must be 2 units in length. So this is 2, 4, 6, 8, 10. This is 12 units in length. And we can clearly tell that the scale factor in that situation, so if that's a 4 and that's an 8, well, we're well able to tell that the scale factor is 2. What else can we figure out here? Well, we actually know something about the area, and it's the image area over the object area is going to be your scale factor squared. So, or your, what they call K squared. Area this, 24. Area this, well, if that's 6, that has to be 12. So 8 times 12 is 96. And then 96 over 24 is 4. So the 96 over the 24 gives me 4, which is my K squared, which means that K is 2. You know, we already knew that even just by looking at the diagram. But there is not only a link between the lengths of the sides of your image and your object, but also the area of your image and your object, and that's the link that there is between the area and the scale factor. Again, you can have a look, try and do a few questions here, all pretty straightforward. See how you get on.